For simplifying radicals, what we want to do is find all the prime factors of the number that is underneath the radical. So I'll just show you what we're doing here, but I'm not going to work this out every time. You want to take the 500 and find out what multiplies together to give you this. You could use 5 times 100. And then you break down the 100 into 10 times 10, and then 10 is 2 times 5 on each of these. All right, so your prime factors here, you're going to have 1, 2, 3 5s, and 2 2s. So the factoring for this is 2 times 2 times 5 times 5 times 5. Those are the prime factors for 500. The next thing we want to do is, if you have a square root, what we are doing is looking for pairs of numbers. We have a pair of 2s and we also have a pair of 5s. The pair of 2s will come outside of your radical as a single 2, because what you're really doing is taking the square root of 4. And the square root of 4 is this 2 that we have outside the radical. Then we also have a pair of 5s, which is really the square root of 25, and that is 5. So that also will come outside the radical. What's left inside the radical is what's not circled, and that's this lonely 5 right here. The values that we have outside the radical, you're going to multiply those together. So your simplified answer is 10 root 5. All right, so let's look at the next problem here. We have this time a cube root of 128. So the prime factors for 128. Let's do this without doing a factor tree. 2 times 64. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So those are the prime factors for 128. Now this time what we are looking for is a cube root. Well, the difference here is, instead of looking for a pair of numbers, you're going to be looking for a group of 3. All right, so we have a group of 3 2s here, and we have a group of 3 2s here. All right, so the first group comes out as a single 2. The second group comes out as another 2. And we are left with 1 2 inside. And the 2's outside multiply together to give you 4 root 2. All right, so the next one is going to be the fourth root of 81. 81 prime factors are 3 times 3 times 3 times 3. Fourth root means we are looking for a group of 4, which we have. There is nothing left underneath the root, so our answer is simply 3. All right, the next one, we have a fraction. With this, you can separate this into the square root of 48 over the square root of 9. These two things are equivalent to each other. Now your denominator, the square root of 9, that comes out evenly to be 3. All right, so now let's look at the square root of 48. All right, so square root of 48, that's 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. All right, so we're looking for pairs of numbers because it's a square root. We have 2 pair of 2's. Each 2 will come outside the radical. You'll be left with a root 3 underneath. The two 2's multiply together to give us 4. and this is all over 3. All right, so let's look at throwing some variables in here. This next one, we're going to have square root, and the 60 breaks up into 2 times 30, which is 2 times 15, and 15 is 3 times 5. Now, the variables, we have x to the 3rd, y to the 6th, and z squared. So looking for pairs of numbers, we've got a pair of 2's. That will come outside the radical as a 2. Inside the radical, you're going to be left with the 3 times 5, which is 15. All right, so now if you look at your x's, you can think of x cubed as x times x times x. You have a pair of x's that will come outside the radical, and you're going to have this 1x left inside the root. Now if you think about the y's, y to the 6th power is 3 pairs of y's. So all of those will come out because they all get grouped together, and that will become y to the 3rd outside the radical. And the z squared is z times z, that's 1 pair. So you have a z outside, nothing left inside. Now another way that you can think about this particular problem is if you take these x values, y values, and z values and expand them all into x, 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 y. You got 6 of these y's, and then 2 z's. All right, so we have a pair of x's. We have 1, 2, 3 pair of y's, and 1 pair of z's. So the only thing left underneath the radical is this 15 and this x. This came out as an x. These y's came out as y cubed, and then this z came out as a single z. All right, let's work through this last one here kind of quickly. This will be 4th root. 80 is 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. All right, so we have 4th root, which means we're looking for groups of 4. So we have one group of 2's that will come outside the radical. We are left with a 5 inside the radical. If we have 6 A's, we can get one group of 4 out of that, and that will leave us with 2 A's inside the radical. The B's, we can get one group of 4 out of this, with one B left over inside the radical. Now if we have fractions, we're going to first reduce the fraction that is inside the radical and then simplify the radical. Alright, so if you'll notice, we have a negative exponent right here. That means we're going to take this variable and move it to the numerator. So when we move this to the numerator, it becomes x to the 4th times x cubed, which is going to give us 32x to the 7th over 25. Now we can break up this radical into the square root of 32, which square root of 32, let's go ahead and break that apart. That's going to be 2 times 16, which is 2 times 8, which is 2, 2, 2, x to the 7th, over the square root of 25. Now, square root of 25 comes out evenly. that is 5. In the numerator, square root, so we're looking for pairs of numbers. The 2's, we have 2 of those, so that's going to come out as 4. We're going to have 3 pairs of x's, and that'll come out as x cubed. We are left with a 2 and a single x underneath the radical. So this is our simplified answer here. All right, so on the next one, we have negative exponents, so we move these to the numerator. So when we move this to the numerator, this is going to become 3 to the third times 3. Then we have x, and we have y to the third, and we need to move this x also to the numerator, which makes it x to the 5th power. Now, 3 to the third times 3 to the first is going to give us 3 raised to the 4th power. We have x, and we have x to the 5th. That combines to give us x to the 6th. And then we have y cubed. All right, so square root, we're looking for pairs of numbers. We're going to have 2 pairs of 3's. So that's going to come out as 9. We're going to have 3 pairs of x's. So that's x to the 3rd. We're going to have 1 pair of y's. Inside the radical, the only thing we have left over is a single y. All right, so now we're going to talk about rational exponents and how they work. When you have a rational exponent, that means that your exponent is simply a fraction. Now, the top number of your fraction and the bottom number of the fraction represent 2 different things. The top number, in this case a, represents the power, and the denominator b represents the root. Now, there are 2 ways of being able to write these answers. You can either take the b root, which is your denominator, your b root of x, and then find that answer and raise it to the a power, or you can take x, raise it to the a power, and then find the b root of that. So this is what I mean. Let's take a look at a problem here. Instead of x in this problem, your x is being replaced with a 9. So your answer here then will be a 9 right here. The root is the b value. In this case, the b value is 2. That simply means this is going to be a square root. And then we raise this to the a power. Well, the a value here is 3. So that is the square root of 9 raised to the 3rd power. Now, the other way of writing this is to write it as the 9 raised to the 3rd power, and then take the square root of that answer. So if you think about that, which one of these 2 is going to be easier to work out? Raising 9 to the 3rd power, which is 729, and then try to figure out the square root of that, or figure out the square root of 9, which is 3, and raise that to the 3rd power. That's much easier to do because we're dealing with smaller values. All right, so the square root of 9 is 3, and 3 raised to the 3rd power means 3 times 3 times 3, which is 27. All right, on the next one, we have 8 raised to the 2/3. Remember, your denominator is the root, and that's what we want to do first all the time, is going to be finding the root of this value. So this is going to be the cube root of 8, and then we're going to raise that to the 2nd power here. Well, the cube root of 8 is 2, and then squaring that is going to give us 4. All right, so the next one is going to be 27 raised to the 1/3, which means cube root of 27, and then raise that to the first power. Well, that simply means cube root of 27, which is 3. All right, so the next one is going to be the 4th root of 16, and then raising that answer to the 3rd power. Now the 4th root of 16 is 2, because 4 2's multiplied together give us 16. So the inside here, this comes out to 2. Now 2 to the 3rd power is equal to 8. So anytime you see a 1/2 power, what that means is the denominator is a 2, so that is a square root. And raising to the first power then means you're really just taking the square root. So the square root of 81 is 9. This means the square root of 49, which is 7. This one we need to take the square root of 36, which is 6, and then raise that to the 3rd power, which is 216. And then the last one here, this just means a cube root raised to the first power. So cube root of 64 is 4. Raised to the first power is still 4. All right, let's look at some equations and solving equations that have exponents that are rational values. Starting with this first one, what we want to do is isolate the radical part of your problem. All right, so the radical part of this equation is x to the 2/3. The radical is the term or the part that has the fraction for an exponent. So solving this, we start out with moving the addition and subtraction parts first. So we have 2x to the 2/3. We're going to add the 4 over to the other side, giving us 18. And then we're going to divide by 2, which is 9. Now to solve this, remember when you have an equation, you can do just about anything to the equation as long as you do the same thing to both the left side and the right side of the equation. Now, our goal with this is we need to get down to simply x equals some number here. What that means is we need to get rid of this exponent right here. We can get rid of this exponent by raising this to the reciprocal power. So if we raise this to the 3/2 power, and again we have to do it on both sides of our equation, we would end up multiplying the exponents because we have parentheses. 2/3 times 3 over 2 is going to give us 1. So that's x to the first power right here. Now we have 9 raised to the 3/2, which means we're taking the square root of 9, which is 3, and then raising that to the 3rd power, which is 27. All right, the next one, the radical part of this problem is this, because it's raised to the fraction exponent, rational exponent. So we need to move the 2 and the 6 to the other side of our equation. Always start with your addition and subtraction stuff first. So that's going to give us 6 parenthesis 3x plus 5 raised to the 1/4 equals 12. We then are going to divide by 6, which will give us 2. Since our exponent is 1/4, the reciprocal of that is 4 over 1, or just simply 4. So what that means is that we are going to raise both sides of our equation to the 4th power. And when we do that, that cancels out the exponent on the left, leaving us with 3x plus 5. And then 2 raised to the 4th power is 16. So now solving for x, you're going to subtract 5 and then divide by 3. And get used to just leaving your fractions as improper fractions. Alright, 2 more problems here and then we'll be done with this. Isolate the radical part, that is this. So we're going to start off with moving the 5 and then moving the 2. So moving the 5, we're going to subtract it, which will give us 128. Our next step will be dividing by 2, which is 64. We have now isolated the radical, so we're going to raise both sides to the reciprocal power. So raising both sides to the 4/3. This will then become 2x minus 1 equals 64 raised to the 2/3. Now this means cube root of 64, which is 4, and then 4 squared is 16. So we now have 2x minus 1 is equal to 16. Adding 1 and then dividing by 2 will give us 17 over 2. Oops, I need to back up a little bit. This is not the 2/3 power, this is the 4/3 power. And this would be the cube root of 64 is 4 raised to the 4th power. 4 to the 4th power is 256. Adding 1 is 257. Dividing by 2 is 257 over 2. Almost made a mistake there. All right, so the next problem, the radical part of this problem is right here. So we're going to start out by moving the 7. That's going to give us 4x to the 2/3. Subtracting 7 will be 64. And then divide by 4, which is 16. Now we're going to raise both sides of our equation to the reciprocal power, which would be 3 over 2. That'll give us just x on the left side equals 16 to the 3/2, which means square root of 16 is 4, and then 4 cubed is 64.